June 12, 1944. The morning mist clings to the waters off Arromanches where the impossible has taken shape against the Norman coastline concrete caissons. The size of city blocks rise from the seafloor like sleeping giants awakened their gray forms. Stretching 2 miles into the English Channel, the rhythmic thunder of waves crashes against structures that should not exist, artificial harbors where nature provided none, floating docks that carry the industrial might of democracy across treacherous waters. In the distance, Liberty ships queue like patient cattle, their hulls heavy with the machinery of liberation. The salt air carries the sound of diesel engines, the clang of steel against steel, and something unprecedented in the history of warfare, the mechanical heartbeat of a portable civilization being assembled under enemy fire. This was not merely engineering. This was the manifestation of American industrial philosophy, made manifest in concrete and steel, the audacious belief that any problem, no matter how impossible, could be solved with enough resources, ingenuity, and democratic determination. What German commanders witnessed on these beaches challenged every assumption they had made about warfare logistics and the fundamental nature of military possibility. The German High Command had built their entire defensive strategy on a single, seemingly unshakable premise that any invasion force must capture a major port within days or face inevitable collapse. Field Marshal Erwin Rommel himself had declared it impossible for the Allies to sustain operations on open beaches. They must take Cherbourg, he had told his staff officers with characteristic confidence, or they will be pushed back into the sea within a fortnight. The logic was irrefutable. An army of over 1 million men would require thousands of tons of supplies daily. Without the deep water facilities, rail connections, and cargo handling equipment of an established port, such massive logistical demand seemed insurmountable. This assumption became the cornerstone of German coastal defense strategy, concentrating the heaviest fortifications around major harbors, while leaving the beaches of Normandy relatively lightly defended. German generals had laughed at Allied seaborne logistics. No ports meant invasion failure within 2 weeks. Their Atlantic wall stretched across 1670 miles of European coastline, its most formidable bunkers guarding Calais, Le Havre, and Cherbourg, the obvious targets for any amphibious assault. These were the places where concrete walls stood 40 feet thick, where massive artillery pieces commanded the approaches, where thousands of obstacles and mines turned harbors into death traps. The Wehrmacht's finest minds had calculated that the Allies faced with such defenses would have no choice but to throw themselves against these prepared positions. And there, in the killing fields of their choosing, the German defenders would annihilate the invasion forces. But on the morning of June 6th, when Allied forces splashed ashore on the beaches of Normandy, far from any major port, German commanders felt the first stirrings of unease. Initial reports seemed almost routine enemy landings at scattered points along a 50-mile stretch of open coast. Surely, this was the feint they had expected, the diversionary attack before the real assault on Calais. Hitler himself remained convinced that the main blow would still fall where German strength was greatest. Yet as the hours passed and intelligence reports filtered back from the front lines, a disturbing picture began to emerge. The Americans and British were not just landing troops, they were landing what appeared to be entire factories. Massive concrete structures were being towed across the channel and sunk in precise formations. Offshore ships were anchoring not in natural harbors, but in artificially created calm water. Most perplexing of all, vehicles were driving off LSTs not onto beaches but onto floating roadways that stretched far out to sea, as if the invaders had brought their own docks with them. German officers studying aerial reconnaissance photographs found themselves confronting images that defied comprehension. Oberstleutnant Fritz Ziegelmann of the 352nd Infantry Division later wrote, "We observed with growing astonishment the enemy's construction activities in the sea. Concrete blocks larger than our largest bunkers were being positioned with mechanical precision. What we were witnessing was not improvised beach supply, but the systematic construction of what appeared to be permanent port facilities. The Photographs showed structures that dwarfed anything in German military engineering phoenix caissons measuring 204 feet long, 56 feet wide, and 60 feet high, each weighing over 6,000 tons. These weren't temporary expedients, but massive infrastructure projects being assembled under fire. The scale of what the Allies were accomplishing became clear as German intelligence pieced together the full scope of Operation Mulberry. The enemy had not merely planned to capture ports, they had decided to bring their own. Each Phoenix caisson contained enough concrete to build a substantial bunker, yet the Allies were using them as disposable breakwater components. The implications were staggering if the Americans could treat 6,000-ton concrete structures as temporary installations. What did this reveal about their industrial capacity? What kind of nation could afford to build artificial harbors larger than most natural ports and then abandon them after a few months of use? As the artificial harbors took shape off the Norman coast, German commanders found themselves witnesses to a demonstration of industrial philosophy that shattered their understanding of warfare itself. The Wehrmacht had spent 2 years constructing the Atlantic Wall using 13 million cubic tons of concrete and 15 million tons of steel, a massive undertaking that represented the peak of German engineering effort. Yet here were the Americans accomplishing an equally impressive feat of construction, not over years, but in a matter of days. Not on friendly soil, but under enemy fire, not with forced laborers, but with volunteer engineers who worked with a dedication born of democratic conviction. The floating roadways proved particularly mystifying to German observers. These whale sections, each 480 feet long and supported by beetle pontoons, created flexible highways that could rise and fall with the massive channel tides while maintaining constant access to the shore. German engineering doctrine emphasized permanence and solidity. Their bunkers were built to last 1,000 years. But here was a different philosophy at work, one that valued adaptability over permanence, mobility over static defense. The Americans had created ports that could be assembled in sections, towed across an ocean, and reconfigured as needed. It was engineering as jazz improvisation rather than classical symphony. The symbolic power of the Mulberry harbors extended far beyond their practical function. Each Liberty ship that docked at the artificial piers represented not just cargo delivered, but ideology made manifest. These vessels mass-produced in American shipyards at a rate that defied German comprehension, carried more than ammunition and supplies. They carried the promise of American abundance. While German soldiers subsisted on increasingly meager rations, American GIs unloaded crates of everything from candy bars to cigarettes, from fresh meat to complete meals sealed in cans. The contrast was not lost on German prisoners who watched this cornucopia flow ashore. Abundance was intentional, a projection of American industrial might designed to demoralize as much as to supply. German intelligence reports noted with growing alarm the sheer variety of equipment coming ashore, not just the basics of warfare but luxuries that German forces had not seen in years: chocolate, coffee, cigarettes by the carton, medical supplies in seemingly unlimited quantities. One captured Wehrmacht document observed, "The enemy appears to possess industrial resources of unlimited scope. They waste in a day what we conserve for weeks." But it was not merely the quantity that shocked German observers, it was the casual efficiency with which these artificial harbors operated. Within days of D-Day, Mulberry B at Arromanches was handling tonnages that exceeded many established European ports by D+10. Over 6,000 tons of supplies were flowing ashore daily through artificial facilities that had not existed a week earlier. By D+16, this figure had doubled. The Americans had not just solved the port problem, they had reimagined it entirely, creating something better than what nature had provided. The June 19th storm provided the ultimate test of both engineering and resolve. For 3 days, gale-force winds and mountainous seas battered the artificial harbors with a fury that exceeded their design specifications. Mulberry Of the American harbor at Omaha Beach was largely destroyed. Phoenix caissons, weighing thousands of tons, were shifted like toys. Whale roadways snapped under the assault, and months of construction work seemed to vanish in a matter of hours to German observers monitoring the chaos. It appeared that nature had succeeded where the Wehrmacht had failed. The artificial harbors were being reduced to twisted wreckage by forces beyond human control. Yet what followed the storm revealed the true genius of American logistics philosophy. Rather than despair at the destruction, American engineers immediately began adapting. Salvageable components from Mulberry A were transported to strengthen Mulberry B. The British harbor was quickly repaired using spare parts and innovative modifications. Most remarkably, the Americans discovered that even without their artificial harbor, the sheltered water created by the remaining breakwaters made direct beach landings far more efficient than anyone had anticipated. They continued landing supplies at rates that matched pre-storm levels, proving that the Mulberry concept was not a single point of failure, but a flexible system capable of multiple configurations. This adaptability struck at the heart of German military doctrine. The Wehrmacht excelled at executing carefully planned operations, but struggled when forced to improvise. German engineering emphasized precision and permanent structures, built to exact specifications that performed as designed or not at all. The American approach revealed a different philosophy: engineering for flexibility, building systems that could fail partially while maintaining overall function. It was the difference between a Swiss watch and an American assembly line, both remarkable achievements, but reflecting entirely different approaches to solving problems. Sight of American vehicles rolling off LSTs onto floating roadways that flexed with each wave became a recurring image in German intelligence reports. These roadways, dismissed by some German officers as makeshift expedients, demonstrated engineering principles that the Wehrmacht had never encountered. Rather than fighting natural forces, the Americans had designed systems that worked with them. The flexible joints that allowed whale sections to move independently prevented the catastrophic failures that would have destroyed rigid structures. It was engineering as philosophy, embracing change rather than resisting it, finding strength in adaptability rather than in flexibility. German prisoners interviewed after the war consistently mentioned the psychological impact of witnessing the artificial harbors in operation. Unteroffizier Hans Müller of the 716th Infantry Division later recalled, "We had been told that the Americans were soft, that they could not endure hardship, that they would flee when faced with determined resistance. But when we saw them building entire ports in the middle of a battle, when we watched their ships unloading as if they were in New York Harbor rather than under our guns, we began to understand that we were facing something unprecedented. This was not just another army, this was an entire industrial civilization bent on our destruction." The artificial harbors transformed the strategic situation in ways that extended far beyond logistics. Prior to D-Day, German defensive planning had been based on the assumption that any Allied foothold in France would be temporary and precarious, even if the curious initial landing succeeded. The Wehrmacht calculated that supply difficulties would force the invaders to either capture a major port quickly or face inevitable withdrawal. The Mulberry harbors eliminated this vulnerability entirely. The Allies were no longer racing against time to capture Cherbourg. They had created their own Cherbourg wherever they chose to land. This strategic revolution forced a complete reassessment of German defensive priorities. Resources that had been concentrated around major ports now seemed misallocated. Coastal defenses designed to prevent the capture of harbors were irrelevant against an enemy that could create harbors at will. The entire logic of coastal defense, channeling enemy attacks toward prepared kill zones, collapsed when the enemy could choose any stretch of beach and transform it into a major port within days. The code within days. The broader implications were equally disturbing to German strategic thinking. If the Americans could build artificial harbors, what other impossible feats might they accomplish? Reports began filtering in of equally fantastic undertakings. Pluto, the pipeline under the ocean that carried fuel directly from England to France, portable airfields that could be assembled on any flat ground, floating fuel depots that accompanied the fleet like mobile gas stations. Each new revelation suggested, and co-fashion suggested, an industrial capacity that operated by different rules than German planners had imagined possible. As Allied forces broke out from their Normandy beachhead in late July, the artificial harbors had already fulfilled their primary purpose. Over 2 million men, 500,000 vehicles, and 4 million tons of supplies had flowed through these temporary ports that the Germans had dismissed as impossible. The statistics themselves told the story of industrial warfare's new paradigm. In 6 months, Mulberry had handled more cargo than most European ports processed in an entire peacetime year. The transformation of perception was complete. What had seemed impossible in May appeared inevitable by August. German commanders who had once scoffed at Allied engineering capabilities now found themselves anticipating even more fantastic developments. If the Americans could tow harbors across the English Channel, might they next tow entire airfields? If they could mass-produce concrete caissons weighing thousands of tons, what other industrial miracles might emerge from their factories? Albert Speer, Hitler's armaments minister, captured the German reaction with characteristic precision. To construct our defenses in 2 years, we used 13 million cubic tons of concrete and 1.5 million tons of steel. A fortnight after the landings by the enemy, this costly effort was brought to naught by an idea of simple genius. The phrase simple genius became the epitaph for German defensive strategy. All their elaborate calculations, their massive fortifications, their carefully planned killing fields had been rendered obsolete, not by superior firepower, but by superior imagination. The Liberty ships continued their patient procession through the artificial harbors long after the immediate crisis of D-Day had passed. Each vessel represented not just successful logistics, but successful democracy, the ability of free peoples to organize themselves for unprecedented undertakings. The ships themselves had been produced by American shipyards at a rate of 3 per day at peak production, each one built by workers who had volunteered their labor rather than been conscripted to it. This was the true secret weapon that German commanders had failed to anticipate, not any particular technology, but the industrial energy of democratic societies mobilized for war. The contrast with German production methods was stark and revealing, where German industry relied on forced labor and increasingly scarce raw materials. American factories operated with volunteer workers and seemingly unlimited resources, where German engineers were constrained by shortages and forced to design for economy. American engineers could pursue optimal solutions, regardless of cost. The result was visible in every component of the Mulberry Harbor's Phoenix caissons, built to higher standards than necessary. Whale roadways engineered with safety margins that German practice would have considered wasteful. Backup systems for backup systems that reflected an abundance mentality utterly foreign to German wartime experience. The sound of American diesel engines became the soundtrack of German defeat. These engines powered not just the trucks and ships that made Allied logistics possible, but the generators that provided electric power, the pumps that kept Phoenix caissons properly ballasted, the winches that adjusted pier heads to match changing tides. German forces accustomed to shortages of fuel that limited every operation found themselves facing an enemy for whom energy seemed unlimited. American vehicles moved continuously, their engines running even when parked, their fuel consumption reflecting a nation that had never learned to ration gasoline. This mechanical abundance became a psychological weapon as effective as any artillery barrage. German soldiers, listening to the constant rumble of American engines, began to understand that they were facing not just an army, but an entire industrial civilization that could afford to waste resources on a scale that dwarfed German conservation efforts. The message was clear: resistance was not just militarily futile, but economically impossible. America could replace every tank destroyed, every ship sunk, every plane shot down, while German losses were irreplaceable. the artificial harbors also demonstrated American mastery of complex systems integration on a scale that German engineering had never attempted. The Mulberry project required coordination between dozens of separate technologies: concrete caissons, steel roadways, floating pontoons, mechanical pierheads, anti-aircraft defenses, communication systems, fuel distribution networks, and cargo handling equipment. Each component had to function independently while serving the larger system. More remarkably, the entire system had to be designed, manufactured, transported, and assembled under combat conditions by personnel who had never worked together before. This systems approach reflected a management philosophy that was quintessentially American: the belief that complex problems could be solved by breaking them into manageable components and organizing talented people to work on each piece. German engineering excellence had traditionally focused on optimizing individual components, building the perfect tank or the perfect aircraft. The Americans revealed a different approach, building adequate components that functioned reliably within larger systems. The result was not German-style technical perfection, but American-style operational effectiveness. The symbolic resonance of the artificial harbors extended beyond their immediate military purpose to embody the philosophical differences between democratic and authoritarian approaches to problem-solving. The Mulberry project had begun not with a directive from supreme authority, but with a suggestion from Admiral Lord Louis Mountbatten at a planning conference. The idea had been met with skepticism and ridicule, refined through debate and criticism, modified by input from engineers and logisticians, and finally implemented by thousands of workers who understood their role in the larger enterprise. This was democracy applied to engineering: messy, argumentative, iterative, but ultimately more innovative than systems based on hierarchical command. German military culture, with its emphasis on obedience and predetermined roles, could not easily replicate this democratic improvisation. When standard procedures failed, German forces typically awaited new orders from higher authority. American forces, trained to think for themselves within broad mission guidelines, adapted spontaneously to changing conditions. This difference became apparent in every aspect of Mulberry operations, from the engineers who modified pier heads to accommodate unexpected tidal conditions to the longshoremen who developed new cargo handling techniques under fire. The combination of fire floating roadways became a particularly potent symbol of American engineering philosophy. Unlike fixed structures that fought against natural forces, these flexible highways worked with the rhythm of the tides, rising and falling in harmony with forces beyond human control. German observers noted with grudging admiration how American vehicles could drive smoothly across surfaces that moved constantly, how drivers adapted to roadways that never remained level, how an entire logistics system had learned to function in perpetual motion. This acceptance of uncertainty, this engineering for variability rather than control, reflected broader American cultural values that German authoritarianism found difficult to comprehend. Where German society emphasized order and predictability, American democracy thrived on change and adaptation. Where German engineering sought to eliminate variables, American engineering sought to accommodate them. The result was visible in every component of the artificial harbor systems, designed not for perfection, but for resilience; not for theoretical efficiency, but for practical reliability under unpredictable conditions. As summer progressed and Allied forces advanced across France, the artificial harbors continued their vital work with mechanical persistence. Long after the immediate crisis of the landings had passed, these temporary installations continued to demonstrate American industrial philosophy through their steady, unglamorous efficiency. There were no more dramatic moments, no spectacular engineering feats, just the daily routine of ships arriving, cargo being unloaded, supplies flowing inland with clockwork regularity. This routine operation proved as psychologically devastating to German morale as the initial construction had been surprising. The Wehrmacht was accustomed to dramatic reversals of fortune, to battles won and lost, to periods of shortage followed by periods of plenty. But the artificial harbors represented something more disturbing: the prospect of American abundance continuing indefinitely, of enemy resources that seemed to operate outside normal patterns of supply and demand. German intelligence reports began to reflect a growing sense of inevitability if the Americans could sustain such massive logistics indefinitely. Then German defeat was not a possibility, but a mathematical certainty. Contrast became more acute as winter approached and German supply difficulties multiplied, while American forces continued to receive regular shipments through the artificial harbors. German units faced increasing shortages of fuel, ammunition, and food. The psychological impact was compounded by captured American supplies, which German soldiers discovered to be superior in quality and quantity to their own provisions. Rations that American troops considered barely adequate seemed luxurious to German forces accustomed to ersatz coffee and sawdust bread. By November 1944, when Mulberry B finally ceased operations, the artificial harbors had completed their strategic mission with overwhelming success. They had sustained the largest amphibious invasion in history, enabled the liberation of Western Europe, and demonstrated the industrial superiority that would define the post-war world order. More subtly, they had revealed the philosophical foundations of American power: the belief that any problem could be solved with enough resources, imagination, and democratic cooperation. The harbor at Arromanches, sections of which remain visible today, stands as a monument to more than military engineering. Those concrete caissons rising from the Norman surf represent the moment when American industrial democracy proved its superiority over European authoritarianism, not through ideology or rhetoric, but through the practical demonstration of impossible things made possible. They embody the American genius for turning the impossible into the inevitable through the systematic application of resources, technology, and free human energy working toward common purpose. In the end, the artificial harbors succeeded, not because they were perfect, but because they were perfectible systems, designed to be modified, adapted, and improved through experience. This was the essence of democratic engineering, not the pursuit of theoretical ideals, but the practical solution of immediate problems, not the creation of monuments to human pride, but the construction of tools for human liberation. The Kunde, floating docks that moved an entire army across the channel, were more than marvels of engineering. They were democracy made manifest in steel and concrete abundance, given form in floating roadways, freedom expressed through the simple act of building harbors where none had existed before. The German commanders who first glimpsed those impossible structures rising from the Norman surf witnessed more than the failure of their defensive strategy. They saw the future taking shape before their eyes. A world where American industrial democracy would set the terms of possibility, where problems would be solved not through force or ideology, but through the practical application of free human energy organized for beneficial purpose. The artificial harbors were not just temporary expedients for a single military campaign. They were the first glimpse of the American century, being built one concrete caisson at a time, one flexible roadway section at a time, one Liberty ship cargo hold at a time, until the impossible became inevitable and the future of human freedom was secured by the simple genius of democracy applied to the ancient problem of getting from here to there. The echoes of diesel engines and the splash of concrete caissons settling into their positions have long since faded from the waters off Normandy. But the principle they embodied, that free peoples organized for common purpose can accomplish things that seem impossible to the imagination of tyranny, continues to shape our world. In every infrastructure project that seems too ambitious, every engineering challenge that appears insurmountable, every moment when democratic societies face seemingly impossible odds, the spirit of the Mulberry harbors reminds us that there is no problem so great that it cannot be solved by enough Americans working together with sufficient determination and unlimited quantities of concrete steel, and the simple genius of freedom applied to the practical problems of Human existence,